Everyone, can you hear me? Hello.
Yes, Manjunath, we can hear you. You can continue. You can
Yeah.
start.
So this is the same way that first 15 minutes we'll be having the doubt session, then we'll be starting the session, or any change in the plan?
No change. The
Yeah.
people can pose their questions, and you can take up some question from yesterday's topic, and we can continue with that until they post the questions in the chat box.
Yeah. Okay, ma'am. So in the yesterday's class, we have discussed regarding our major components of the vehicle, where which I can call it as what vehicle is made up of, or what car is made up of in generally. So most of the questions in the yesterday's session we have completed. So if there are any questions pending in the yesterday's class, or if anyone is getting any questions regarding the yesterday's session, you can post them in the chat box, because as per our plan, we have scheduled that initial 15 minutes will be for the doubt clarification of the previous session. Then we'll be having something called our continuation of the session from after 15 minutes. This is what our scheduled thing.
Manjunath, Satya has a question, I guess. He raised his hand. Satya, can you ask your question? You can unmute yourself now.
You've disabled the chat, so that is the only thing to ask.
Oh, chat is disabled.
Oh, okay. Thank you.
Okay.
Yeah.
Yeah, guys. Now you can post your questions in the chat box if you are having any questions. Chalo. So if you are not having any questions, let me continue. Sir, is solar car available in the market? Yeah, that's a good question by Sanket. See, Sanket, there is a possibility of creating a car, or there is a possibility of using a car by with the help of the solar. But what I can say is, as of now, we don't have any particular solar-based cars in the market. See, one thing what we can do is, whenever the vehicle needs the electricity, okay, whenever the vehicle needs the electricity, that means I can say that whenever motor needs the power, in generally that power will be giving from any other power sources, like our batteries and all. Here the battery need to be recharged. Okay, here the battery need to be recharged. So the recharge of the battery can be done. Okay, the recharge of the battery can be done with the help of solar also. So you can also include the rooftop, or where you can keep your vehicle roof as the solar. That is one of the option which you can use. But as of now, we don't have such models, but they are in R&D. Am I clear for your question? Yeah. Next question I got something is, how design considerations are considered. Yeah, we are having the specific design considerations where design considerations are something where we need to design the powertrain. Okay, so whenever we are planning to design the powertrain, we need to check the proper battery and motor calibration. So in this case, what I can say is we will be designing a vehicle in such a way that where I'll be calculating the vehicle characteristics, I'll be calculating the number of life cycles, I'll be calculating the battery capacity, I'll be calculating the motor capacity. Then we'll be calculating the range which comes under your specific energy. Then we'll be calculating something called our specific power. So all these things are calculated. Then we will be making a proper designing here. So there are various terminologies or various categories where we need to consider, or there are various variables we need to consider for designing a vehicle. Then can increase the capacity of the battery. Yes, you can increase the capacity of the battery without any doubt, because the point is that if you increase the chemistry inside the battery, you can increase the capacity of the battery. But one thing you need to remember is, if you increase the battery capacity, range will be increased. In the same manner, the what I can say is the cost will also be increased. Okay, because one two-wheeler example I can say that where whenever we are dealing with some two-wheelers, we'll be having the low-speed vehicles and high-speed vehicles. So in case of the low-speed vehicles, the batteries I'll be using is 72-volt batteries or 60-volt batteries. Whenever I'm coming for the high-speed vehicles, there I'll be going for 112 or 120. So from variant to variant, the battery capacity is increasing, which means that the range is getting increased, which means that what properly I can say is the cost is also getting increased. So there is no need to worry regarding the increase of the battery capacity. Is there, sir, is there any, yeah, just a second. Is there any baseline for weight to power ratio for EV design? Yes, we will be having the weight to power ratio here. We need to consider the proper weight to power ratio. Regarding that ratio, while you are seeing the simulation, there you'll get to know how to calculate that weight to power ratio. Very soon you'll get to know that. Then, sir, battery life is line, sir. Sir, battery is lifeline. Are you asking about any KBC lifeline? I'm not getting here which lifeline you are asking. Vijay Reddy, can you repeat your question once again? Next, how many kilometers can EV travel when it's full charged? Yeah, it's a very good question. See, the point is that it depends on variant, Andy. Okay. See, whenever I'm going for Tata Tiago vehicles, okay, in such cases, I'll be going for 300 or 280 kilometers in full charge. Whenever I'm going for Tata Punch, I can go for 320 kilometers. Whenever I'm going for Tata Curve, there I'll be going for 580 kilometers. If I'm going for Mahindra BE60 type vehicles, there I'll be having something called my 685, 585 kilometers of the range. So from variant to variant, the capacity or the range will be increased. Next, when all vehicles in India be electric vehicles, Priyanka, I think, I hope, I wish by 2050 or 2060. Okay, if the government keeps a proper pressure on the people who are using IC engine vehicles, and if the government increase the taxes in a rude manner, where the people should get fear that if they use IC engine vehicles, they need to pay lots of bucks for the government. If that is the scenario, then I can say it's by 2050 or 2060. But if the awareness is not proper, it may take up to 2000 also. So it depends upon how aware we are getting. The same thing what we are discussing also. These sessions, these webinars, these seminars is to educate you people, is to bring awareness in new people. See, one thing I can say is that I think all of you seen the Tagore movie, if I'm not wrong. In the Tagore movie only, Chiranjeev will be saying that no mugurki yappu, a mugurni inkoka mugurki yappamani yappu. So that is what the scenario that where we need to learn, we need to get aware, and that awareness should be given for few people. That awareness should be given for few people where if the awareness will reach to the ground level, then only we can expect that complete segment will be changed into electric vehicle. Is wireless charging possible for EV? Yes, wireless charging is definitely possible for EV, where you'll be having the coil mechanism, same as your iPhones, where you will be doing the wireless charging, the contact charging, and even in the EV, you can also have the contactless charging, but it is somewhat expensive technology, where as of now we are not using. They have their own drawbacks, but it is possible. How I design a charging infrastructure. For designing a charging infrastructure, you need to understand the chemistry of the battery first. Then you need to see how the chemistry need to be built uh, for the battery. Then coming for the charging infrastructure, if I'm not wrong, you're asking for the charging you are giving for the vehicle, or you are asking regarding the charging stations. So can you please clarify it? Sir, car EV battery life. Coming for the car EV car battery life, in generally they'll be giving the warranty of 6 to 8 years, which I can say that that is more than enough for the battery as of now in these situations. So I can say that 8 to 10 years, same as our engine vehicles and all. I need to know about regenerative process. Venkatesh, what I can say is regenerative braking is that whenever the brakes are applied, there will be some loss in the energy. There will be some loss of energy. So whenever you are having the loss of energy, that energy will be reutilized with the help of the regenerative braking mechanism, where the mechanical energy is converted into electrical energy again with the help of the generator, and that is given for your traction battery, where the battery can recharge. How much last range of battery to travel vehicle? How much last range of battery to? Are you asking the maximum range? So just now I have explained that. See, the point is that from variant to variant, the capacity is getting increased. Yeah, that's for the regenerative braking mechanism, Deepanjay. Yeah, the cooling system means the battery management system along with the thermal system will be included. Yeah, someone is asking that how can I decrease the watt hour per watt hour per kilometer in case of the electrical usage. One thing I can say that reduce the energy consumption by optimizing the driving habits. If you can optimize the driving habits, then you can easily reduce it. And the proper vehicle maintenance and proper energy efficient using by these methods, you can reduce it. Yeah, see, the point is that if you, how can the fast charging technology be improved to reduce the charging uh, time for electric vehicles? What I can say is that if you are going for, it all depends upon the variant of the chargers we are using and the internal resistance we are using for the batteries. So that is the one case, and there are many other methods to reduce the time. Not even the fast chargings, even if we completely change the batteries also, we can change the charging times. Then if we switch it in the supercapacitor mechanism, then also see, the point is that whenever you are coming for the supercapacitors, if a battery is taking 7 hours to charge, but if I use the supercapacitors, the same supercapacitor which is equivalent to battery can be charged in 7 minutes, where you can save hours of time. So these all are under R&D as of now. Why is the time taken to charge the battery? Because inside the battery you will be having the electrons where the oxidation and reduction need to be happen. So for that oxidation and reduction, the time will be taking. So why the time is taking for charging your mobile phones? Is your mobile phones are charging in 30 seconds or 28.5 seconds? Yes, that is your regenerative braking, Harish. Which type of battery is lighter but have more power capacity than other times? That is your lithium ion batteries. Lithium ion batteries will be light in weight. They'll be having the more withstanding capacity, but they are very sensitive also. Someone is asking question that which type of battery is safe, either NMC or LFP. Yeah, the lithium iron phosphate batteries are generally considered as safer than your nickel batteries, Sandy. Because whenever you are cupping for the lithium batteries, the thermal capacities will be somewhat good, and thermal runaway will be somewhat lesser as compared to your nickel metal cobalt batteries or nickel manganese cobalt batteries. So for BMS designing and all, I'll let you know what are the parameters need to be considered, how the BMS will be working very soon whenever I'm dealing with the batteries. Will India tune for electric vehicles, and how many years it will say? As I said that it may take 20 or 30 more years. See, if you make the system running by using the generator mechanism, it is like you are using motor to rotate the windmill, and the same windmill energy again you are using to rotate the motor. So there is no utilization there. So it is not that proper mechanism. How do EVs affect the electricity demand and grid? See, the point is that EVs will consume very, very less amount of power. So that may not occur a larger burden. If the EVs, the on-road vehicles are increasing, then automatically the burden on the electricity will be increased, and automatically the power generation need to be increased. But as of now, we are having the surplus power, which is more than enough for our more than enough for electric vehicles. So next question, I'm having a few other questions, and I'll quickly wind it off these questions. Yeah, someone is asking that do the batteries will automatically stop the power consumption? Yes, they'll automatically stop the power consumption because of the cuttings you will be having. Then what are the design considerations? As we discussed, while you are getting the designing, you will get to know. Okay. What are the design considerations for electronic systems in a dual battery switching system in two-wheel? Yeah, I'll let you know, Andy, while I'm discussing about regarding your designings and all. How we can increase the regeneration. If you can use if you can waste more energy, then you can increase the regeneration, or else you need to increase the generator capacity. But it automatically increases the weight of the vehicle. Instead of waiting the time, instead of wasting the time for charging, you can also use the solar rooftop. But installing the solar rooftop may also cause the higher cost. See, the point is that whenever we are discussing about anything, we'll be getting a number of ideas, but we need to think that idea in economical way where it is suitable for our environment. Okay. So an economical distribution, economical utilization is also more important. See, regarding the batteries exploded and all, there are many reasons. Even if there are no proper chemistry, also the batteries may exploded. But as of now, we don't have such scenarios. As of now, we are not listening that cases. And in future, there will be these conditions are nearly avoidable. You put battery to charge, then the battery. I think I have already answers for all these questions. You can't reuse battery, and once the life cycle is done, it is difficult to reuse battery. Yeah, whenever you are dealing with this pollution regarding the electrical power generations and all, to reduce that only the solar system is also including. So the point is that we are not completely into the renewable. We are the semi-renewable. Our electric vehicles are semi-renewable. So the completely renewable is something that where the energy also generated with the help of the solar and wind powers. Yeah. So I think now I can say only the repeated questions. So we are done with the majority of the questions. Yeah, you can use them as a windshield on your rooftop. But the point is that how much cost it is taking if you properly analyze the cost terminologies. Okay, the cost will be very high comparative to the normal vehicle. So whenever the cost is increasing, then automatically there will not be the proper sale for that vehicle. So this, see, I can say that the solar implementation on the vehicle is one of the good idea. But as of now, there are few problems for that. Okay. See, the point is that whenever you are trying to implement the solar panels on the electric vehicle, here it will be working for the conversion, it will be working for the charging and all. But whenever you are coming for the cost point of view, that is one thing where we need to check. And one thing is how the solar is tracking the power, how to get the touchmetal angle and all that need to be calculated. And if we are keeping a if we are keeping a normal panel, okay, which the capacity of the panel is very low, then there is no use of keeping that panel on the solar rooftop. No, as of now, in case of the DC family, BLDC motors are most accurate, which can also be used as a hub motors. For joining the electric vehicle field, which tools are required? The tools like your the proper basics. As of now, the market is looking for the proper maintenance and design engineers. For the designing, you need to have few other different tools like your MATLAB, AutoCAD, and all. Coming for the basics, where the proper working of the vehicle to understand the understanding of proper working of the vehicle is important. For joining the electric vehicle, yeah.
Manjunath, sorry to interrupt. I think we can start with the presentation. We have gone with most of the questions. Guys, any unanswered questions, we'll take it up in the last. Thanks for your questions. We'll come back to your questions again.
Madam, can you please allow me to share my screen? Yeah, guys. So if I'm not wrong, in the last session, we have seen the proper.
We can't
Yeah.
see your screen.
I didn't presented any screen. Just let me present my screen. I'm just trying to recap the things. Yeah. So before I'm presenting my screen and all, in the last class we have seen something called let me present first that screen, where you'll get one clarity that where we have stopped in the last class. I think now everyone can see my screen. Let me convert it into the presentation. Yeah. Yeah, where we have seen this one cross-sectional figure, where in which we'll be having something called our engine or motor, then we'll be having something called transmission, then we'll be having something called drive shaft, then we'll be having something called our axle shaft and all, then we'll be having something called differential. Now the thing we have concluded that in a vehicle, for the rotation of the wheels, there should be some rotating energy to be given, that is given by our axles. Okay, then for the axle the power is given by the differential, and for the differential the power is transmitted from the drive shaft. Now this drive shaft is directly connected to the motor shaft. This drive shaft is directly connected to the motor shaft. So whenever the motor will be having its own application, which is that a current carrying conductor is placed in a magnetic field, it may experience some mechanical force. Whenever this scenario is happens, so then the motor shaft starts rotating. Then whenever the motor shaft starts rotating, at the same instant, the shaft which is connected to the motor shaft, that is your drive shaft, the drive shaft will start rotate. So whenever the drive shaft starts rotating, the power is transmitted to differential from their axle. From there, it is transmitted towards my vehicle wheels. Now the point is that we have clear with the transmission and we have clear with all these drive shaft, differential shafts and all. The point is that now we need to see how the motor is giving power and what are the different types of motors we are having, what are the applications of the motors, and how to select the motors and all. Today we'll be seeing them. Yeah. Coming for your motor technologies. So we'll be dealing with something called our fundamentals of motors, classifications of motors. Then we'll be dealing something called our applications of motors and all. Yeah. Okay. Now coming for the fundamentals of the motors. So in generally, if we consider the machines, okay, in generally, if we consider the machine, our machines are broadly divided into two categories, which are our static machines and dynamic machines. Okay. Then whenever we are coming for the static machines, okay. So our transformers are known as the static machines. Then we'll be having something called the dynamic machines. In case of the dynamic machines, we'll be having we'll be having something called generators and motors. Let us keep transformers aside. Let us keep generators and motors aside. Okay, let us keep generators aside. Let us start working on the motors. So, guys, let me know what is the basic classifications of motors we'll be having, or basically your motors are classified into. Can you know the basic classifications of motor? BLDC, AC/DC, synchronous, non-synchronous, then anything else? Fastly, quickly, all the 300 need to respond. What about the remaining people? Are you there? Everyone, can you hear me? Guys, can you hear me properly? Yes, yes, yes. See, the point is that I'm getting S's, but I'm not getting answers. Yeah. So, yeah, DC series shunt. Okay, so before going into the series shunt, before going into the different things, okay, what are the different types of motors you'll be having, Tilak? What is the basic categorizations in your motors? Yeah. Let me explain you people that basically your electric motors are classified into DC motors and AC motors. Okay, basically your electric motors are classified into DC motors and AC motors. Then whenever we are coming for the DC motors, we'll be having something called brushed DC motors, as well as we'll be having something called brushless DC motor. Okay, so in the DC motor segment, you will be having two different types of DC motors. One is the brushed DC motor and one is brushless DC motor. And then whenever you are coming for the segment of AC motors, so in case of the AC motors, you will be having something called your synchronous motors as well as asynchronous motors. Okay, so in the asynchronous motors, you will be having something called your squirrel cage and wound rotor type. Then in the synchronous, you will be having single phase and three phase. Okay, so as of now, let us categorize the motors up to here. Okay, so basically these are the three different categories of two different categories of motors we'll be having. So in that we'll be having the DC type of motors, AC type of motors. So first let us start our session with the DC type of motors, then we'll jump into the AC type of motors, and then we'll conclude what are the motors we'll be using in the real-time scenario that are in the real-time electric vehicles. Now, whenever I'm coming for the working of the motor, can anyone say that what is the working principle of the motor? Can you people say that what is the working principle of the motor? Yeah. Most saying the conversion principle of the motor. Yeah, it will be converting the electrical energy into mechanical energy. Okay. Now, whenever I'm coming for the proper working of the motor or proper definition of the motor, what I can say is that a motor is an electrical machine which consumes the electrical energy, and it will do specific work and convert into electrical energy. Okay. So what your motor will be doing, it will be consuming the electrical energy and converting into different forms of energy. Okay. That may be your mechanical energy, or that may be your heat energy, or that may be your light energy. So if we properly take the motor, in case of the motor, we'll be having something called our electrical energy, which is converted into different forms of the energy. So this is in generally the conversion principle of the motor. And the action-based principle or the working principle of the motor is something that whenever a current carrying conductor is placed in a magnetic field, it experiences some mechanical force, and whose direction is given by Fleming's left-hand rule. Okay. Now, all of you are aware of the Fleming's left-hand rule. Do you know what is Fleming's left-hand rule? Yeah. In case of the Fleming's left-hand rule, what the thumb finger indicating? The thumb finger indicating the direction of yeah. Okay. Someone is saying the magnetic field. Most of the people are saying the force. So this is what the Fleming's left-hand rule will be having, where the force is given by BAL Newton. Okay. Where the thumb finger will be indicating the direction of force, and the forefinger or the index finger will be indicating the direction of magnetic field, and the rotation of your hand will be indicating the direction of current. Okay. Is that clear? Yes. Okay. Yeah. Now, so this is what the motor, the working principle of the motor. So whatever the motor you take, the basic principle it will be following is whenever a current carrying conductor is placed in a magnetic field, it experiences some mechanical force, which the force direction is given by Fleming's left-hand rule. Okay. So this is what the basic direction, working principle of the any motor, or basic action principle of the motor. Now, coming for the selection of the motor, what are the criteria we need to observe, or what are the criteria we need to consider for selecting a motor? Okay. So coming for the selection criteria of the motor, first thing we need to be clear with the efficiency of the motor. A motor should offer proper high efficiency. Then it should have high power and torque densities. Okay, motor should have high power and torque densities. Then your motor should have high controllability, because motor is something that where it is completely controlling the electric vehicle. So motor need to control the electric vehicle. So motor need to have high controllability. Then motor need to have something called wide speed operating range, where it need to offer the wide range of operation properly without any disturbances, because even though in the low speeded operation, or even though in the high speeded operation, it should have the proper full efficiency. Then we'll be having something called our then we'll be having something called our maintenance free operation. See, the point is that these are the motors we are using in the electric vehicles, and mainly the electric vehicles we are using because of the different pollutions we'll be having. And one pollution we'll be having is our noise pollution. So we also need to reduce the noise pollution. Okay, we also need to reduce the noise pollution. So that noise to be reduced. And one more thing we need to remember is that the maintenance should be very, very low in case of the electric vehicles. So to maintain the to offer the low maintenance, the motor should also be very low maintenance vehicle motor. Okay. Then we'll be having something called high reliability. Okay.
Then we'll be having something called our high reliability. Then you need to have proper robustness, and it should be highly cost effectiveness. Some people will be saying that, sir, na దగ్గర పైన ఉన్న ప్రతి ఒక్క కండిషన్ ప్రాపర్ గా ఉంది, but my motor is costing nearly 10 lakhs rupees. Will anyone buy? No one will buy our motor. Okay, so even though we are having all the above characters properly, we also need to have one proper characteristics, that is our motor should be highly cost effectiveness. Okay, so these are about the different types, different selection criteria regarding the motors. Okay, all of you clear with this selection criteria? All of you clear with the selection criteria? What about the remaining people? Are you people enjoying the rain? Okay, because where in my area, I'm having a lot of rainfall today. Whenever the session is started, then it started raining. But I can't see any raining comments in your comment box. The comment section is very low. Okay, so I'm expecting more comments from your side. No rain. I'm expecting raining comments. I'm not expecting rain at your place. Yeah, you may have network issues and all. Okay, no problem. Okay, so whoever able to answer, yeah, try to answer, try to make the session more interactive as we discussed. Okay, in Bangalore, is rainfall is falling. I'm not from Bangalore, I don't know. Please send your area. Please send your rain in my area. So I'll book the Rapido and I'll send it. Please pay the bill. Okay. Yeah. Then someone is saying Kasim Kota, no rain. Yeah, I'm saying, yeah. See, the point is that you understood that there should be the raining comments in the chat box, means which I'm saying that chat box లో comments rain లాగా పడాలని చెప్తున్నాను. Rain గురించి పెట్టమని ఏం నేను అడగట్లేదు. ఓకే, Mateshell full rain. Okay, okay, there are students even from Mateshell, everything very good. Yeah. Chalo. That is Telugu language, Andy, where some of the people in the comment box or in the feedback is also asking to speak me in the different languages. The different languages I can manage is Telugu, Hindi, Telugu and English. Whenever I'm coming for the Hindi, as I said in the day one only, it was like something bhaiya thoda pasdal, and coming for Bengali and all, thoda pasdal bhi nahi aata mere ko. Okay, chalo. Yeah. Nanga Kannada ಬರ್ತದ್ರಿ. No need to worry regarding the Kannada also. Yeah, chalo. Let us come back to our topic. We have seen that different criteria which need to be which need to be fulfilled for selecting the motor. We are done with the criteria. There are few other criteria also. Let me know in further sessions or in further slides. So before going into the further slides, here I'll be having something called what are the different types of motors I'll be using in my electric vehicles. This is the one main thing where we need to think properly, where we need to remember properly, or where we need to look it properly, because these are the motors where I'll be using in my electric vehicles as of now. So those motors are BLDC motors. Then I'll be having something called my permanent magnet synchronous motors. Then I'll be having something called my AC induction motors. Then I'll be having something called my switched reluctance motors. Okay, so permanent magnet interior permanent magnet motors are one which is included in the family of permanent magnet motors only. So let us keep join into that. So majorly we'll be having 4 different types of motors which are used in the electric vehicle: BLDC motors and hub motors. Then you will be having something called permanent magnet synchronous motors. Then you will be having something called AC induction motors. Then you will be having something called your switch reluctance motor. Okay, now let us discuss all these 4 motors. Let us discuss regarding all these 4 motors. Then we'll get a clarity. What are the different motors we need to use, how to use them and all. We'll get to know. Okay, Chalo. So before going into the BLDC motor, let us first look down into the normal DC motor. Okay. So before going into the BLDC motor, let us first look down into the normal DC motor. Yeah. So coming for the normal DC motor here, in generally, if we check the normal DC motor, this is how you will be having the normal DC motor, where you will be having the field poles, where you will be having the what we say field windings, then you will be having something called the shaft, then you will be having something called the commutator, then you will be having something called the armature conductor. Here, what happens whenever this armature conductor or the slots of the armature conductors, which are working as a current carrying conductors, and the field pole along with the windings are acting as a electromagnet. So whenever the power supply is given, there will be uh, the situations the situation created in such a way that a current carrying conductor is placed in a magnetic field, then it starts experiencing some mechanical force. Whenever the mechanical force is experiences, induced EMF will cut the loop, and then the working of the motor will happens. Now this is what the normal DC motor where you will be seeing in your labs and all. Okay, if I'm not wrong, these are the motors where we'll be seeing in our labs for the demonstration and all. And this is something where basically we have studied in intermediate, in BTech first year in the basic electrical engineering itself. The construction of the motor is something like that. You will be having the external part as your yoke. Okay, yeah. Yoke is something that yoke is something that the external part of the external part of the motor, which will be made up of the cast iron or cast steel. Okay, so it will be acting as a part that where it will be protecting motor from external damages. It also one of the reason to create the lowest reluctance path. Okay. Then you will be having something called your poles. Okay, poles are made up of the steel laminations. Okay, poles are made up of the steel laminations, where whenever I am wounding my field windings towards my poles, whenever I'm wounding my field windings towards my pole, whenever the power supply is given, it will be acting as a electromagnet. Okay, I think all of you are aware of the concept of electromagnet, where we have seen the concept of the solenoid and all. Whenever the electricity is passing, it will be acting as a magnetic material, and whenever we disconnect the electricity, then it will be acting as non-magnetic material. Okay, so that is what the happen in case of your electromagnet. Then you will be having something called the armature. Armature is something, the rotating object of the machine, where on the armature body you will be having some slots, and in the slots you will be having armature windings. Okay, then you will be having something called the commutator. Commutator is something which is attached to the same shaft of the motor or the same shaft of the armature, where it is responsible for the conversion of the current from AC to DC or DC to AC based upon the requirement. Then you will be having something called the brushes. Whenever the brushes are there, these brushes are something that whenever the commutator ring passes through the brushes, it will change the terminals of the what we say internal electromagnet. Whenever the terminals of the internal electromagnets are changed, then the polarities will be changing. So based on the change in the polarities, the motor will be running. This is what we have already studied in our BTech first year basic electrical engineering itself. Now here what we need to observe is, if we consider this type of motor, in this motor the brushes are made up of something called your carbon material, where they are continuously in contact with the commutator ring. Commutator ring is something which is continuously rotating. So whenever the commutator ring is rotating continuously, the brushes are in contact with the commutator ring. In that cases, there will be a lots of sparks are occurred, and along with the sparks, the brushes will be getting damaged. So there it creates a noise. It creates the maintenance issue, and whenever the brushes are continuously giving the maintenance problem, automatically the efficiency of the motor is also getting reduced. And here, because of this noise and low efficiency things, these are the motors where we are not using in the electric vehicles. Am I clear regarding the brushed DC motor? Everyone, am I clear regarding the brushed DC motor? What about the remaining, Andy? Yeah. Chalo, very good, very good, very good. Now, the point is that, yeah. Now, the point is that, see, I need to have some DC type of motors where I can directly use my DC power getting from the battery. But if I consider the brushed DC motor, so there are the lots of issues with this brush and commutator ring where I'll be getting the noise, where I'll be getting the sparks and all. Now, without brush and commutator ring, can I use my DC motor? Without brush and commutator ring, is there any possibility to use any DC motor? Not only this motor, any DC motor can we use? అర్థం కాలేదు సార్ వెంకటేష్. నేను ఏమడుగుతున్నానంటే ఇక్కడ కమ్యూటేటర్ రింగ్ బ్రష్ లేకుండా DC మోటార్ని ఏదైనా వాడొచ్చా? ఎందుకంటే ఈ DC మోటార్ కేసులో కమ్యూటేటర్ రింగ్ లేకుంటే, కమ్యూటేటర్ ఇంకా బ్రషెస్ లేకపోతే మనకు మోటార్ వర్క్ అవ్వదు. సో ఈ కండిషన్ ని నువ్వు ప్రాపర్ గా తీసుకుంటే ఈ కమ్యూటేటర్ రింగ్ ని బ్రష్ ని తీసేసి వేరే ఏదైనా DC మోటార్ నేను వాడుకోవచ్చా? ఎస్ 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 ఎస్. Yeah. So what I can do is I can remove these brushes and I can use something called my sensors and all, where I can create a brushless DC motor. Okay. So there is one possibility that where I can use my motor without brushes also, that is my brushless DC motor. Okay. So shall we go into brushless DC motors concept? Yeah. So now the next type of motor will be using something called our brushless DC motor. Okay. So this is what the brushless DC motor, where the motor will be working on the principle that whenever the current carrying conductor is placed in a magnetic field, it experiences some mechanical force. That is what the basic principle it will be acting. As a consequence of reaction, the magnet will experience equal and opposite force. Okay. So here, can you see my picture? Or this BLDC motor is something very important motor. Shall I play one video for this BLDC motor where you will be having the animated experience? If majority of the people says yes, then only I'll play the video. So if everyone reacts, then I'll play one video. Yeah, that's the animated video. Let me show for you people. Just hold for a minute. I'll stop and I'll reshare my screen.
In this video, we will talk about a DC motor, which is the ideal choice for many
Manjunath, we can't
applications
see
where
your
it's needed.
screen.
Reliability.
Manjunath, we can't see your screen. Manjunath, can you hear us? Manjunath, can you hear us? Yeah, guys, Manjunath is not available in the class. Maybe he is connecting back. I request all of you to please be available. He'll be joining soon. Thank you.
Yeah, before I play the video, can you people quickly say where we'll be using the BLDC motors as per your knowledge? Only fans? Fans is one good thing. Mixers, electrical appliances. Do we use BLDC motors in cars, Andy? Yeah, induction motors are used in cars. Induction motors are used in cars. CNC machines. Yeah, I'm getting few answers. Very good. Happy to see them. Small scale industries, large scale industries. Okay. Okay. Car engine cooling fan, RC planes. Oh my God. Yeah, very less people you are saying that electrical bikes. What are the motors you are using in electrical two-wheelers, Andy? Yeah, here comes some are saying some people are saying that you are using induction motors. Some people are saying BLDC motors. Can BLDC motors used as the hub motors? Yes. Okay. Yeah. Now, so BLDC motors can also used as a hub motors. Okay. Very good. Okay. Yeah. Now, whenever you are coming for the BLDC motors, one good thing regarding your BLDC motors are they'll be making the very low noise application. They'll be making the very low noise application. Okay. So that is what one advantage regarding the BLDC motors. And whenever we are coming for the yeah, so during the industrials, yes, the scooties are using the BLDC motors. See, do anyone seen the scooties properly? Have you ever seen the scooties? Yeah, where the motors are placed in scooters, Andy. Wheels, for both the wheels we are keeping. Yeah, for the rear wheel. Now, the point is that whenever we are dealing with the motor technology concept, I have said something that the rotor shaft will be rotating. Whenever the rotor shaft will be rotating, my vehicle wheels will be rotating. That's what I said. But whenever you are fixing directly a BLDC motor towards your rear wheel, how the shaft will be rotating, how the wheel will be rotating, how the shaft will be rotating, how the wheel will be rotating. Did you ever got these doubts? Or after listening to my points, did you ever got these doubts? Yeah. Let us discuss regarding that very soon.
Is the ideal choice for many applications where it's needed. Reliability, low maintenance, less noise, speed control, and low cost. Specifically, we are going to see how a brushless DC motor works. We can assume already by its name that this type of electric motor has no brushes. As we have already seen in our previous video about the working principle of DC motors, the brushes are sliding devices which allow the electricity to flow into the copper coil of the engine. The brushless motors have
Guys, can you people see the video? Is the video is available for you people? Manisha and Akash, can you see the video?
In this video, we will talk about a DC motor, which is the ideal choice for many applications where it's needed. Reliability, low maintenance, less noise, speed control, and low cost. Specifically, we are going to see how a brushless DC motor works. We can assume already by its name that this type of electric motor has no brushes. As we have already seen in our previous video about the working principle of DC motors, the brushes are sliding devices which allow the electricity to flow into the copper coil of the engine. The brushless motors have no sliding elements on the collector. So, this completely solves the problem of maintenance and replacement of brushes and other electrical contacts. JIS, in its catalog, offers a wide range of brushless motors of the major manufacturers. Unlike the common DC motors that use brushes for their functioning, brushless motors do not produce sparking or friction noises within them. This is a very interesting feature of brushless motors, because it allows them to be suitable for use in environments where sparks are dangerous. For example, in environments where
Yeah, guys.
Ignitable gases are present. This type of motor has a rotor with permanent magnets.
Now,
In this
once you see
video,
it,
we will talk about a DC motor, which is the ideal choice for many applications where it's needed. Reliability, low maintenance, less noise, speed control, and low cost. Specifically, we are going to see how a brushless DC motor works. We can assume already by its name that this type of electric motor has no brushes, as we have already seen in our previous video about the working principle of DC motors. The brushes are sliding devices which allow the electricity to flow into the copper coil of the engine. The brushless motors have no sliding elements on the collector, so this completely solves the problem of maintenance and replacement of brushes and other electrical contacts. JIS, in its catalog, offers a wide.
yeah, guys, most of the people are getting some disturbances while playing the video. So for you people, what I can do is I can share this video directly into the group where you can later look after this video. Now let me continue with the thing where I have stopped. Yeah. Now can you see my screen, everyone? Yeah. This is what we'll be having, something called the BLDC motors will looks like. Okay. So here, if we observe the proper BLDC motor, here the torque is generated or the torque is produced because of the force of interaction between the electromagnetic stator and permanent magnet rotor. Okay. So here, see, the point is that electrical engineering is something that where you need to imagine. Okay. So imagination plays the key role. Now imagine that these are the two poles where the C and C dash are the two poles where I'll be having something called my current carrying conductors. Okay, so before going into the BLDC motor, one thing I want to say here clearly is, in case of the BLDC motor, we'll be having something called permanent magnets and electromagnets. So whenever you are having the current carrying conductors, whenever the electricity is given to that current carrying conductors, it will be acting as an electromagnet. And whenever, okay, so those electromagnets are kept on the stator, then you will be having something called the permanent magnets, which is kept for the rotor. Okay. So just now I asked one question that can we use how directly we can keep this motor towards our wheels. Okay, so this is what the type of the motor we will be having, where I'll be having internal stator and external rotor motor. Okay, so if I consider this one, the external part is the rotor and the internal part is the stator. Now here what happens means, whenever the current supply is given, so by default you will be having the north pole and south pole for the rotor, because rotor is made up of the permanent magnet. Now whenever we are coming for the stator, in case of the stator, we'll be having 2 to 8 different sets of poles we'll be having. This is in generally the three pole pair motor. So if we take the example of these three pole pair motor, so in this case, we'll be having the 3 set of poles in the stator and one rotating magnetic one rotor, which will be having the permanent magnets. Now, whenever the current supply is given, so imagine if this pole is getting the, if this is the one where getting the power as a south pole, and where this is acting as a north pole, because we are aware of the solenoid, whenever the current carrying conductor, whenever the current is passing through the conductor, it will be acting as a magnet. So if this magnet is, if this pole is acting as a south magnet, if this pole is acting as a north magnet, then what happens? Always you will be having the force of attraction. Always you will be having the force of attraction. Now, whenever these two poles are trying to attract, okay, whenever these two poles are trying to attract, then due to this attraction, the current will be induced or the energy will be induced into the next alternative pole, and this will become as a dummy pole, and this will become as a dummy pole. Now, again, what happens? Here, the north pole will be coming towards here. At this instant, this will be acting as a dummy pole. This will be acting as a south pole. Then again, our north pole will tries to attract this south pole. In this method, the rotation will be continued. So whenever the rotation is continued, there you will be having the proper rotation of the rotor. If I can fix a tire for this rotor, then it will be acting as a proper vehicle. Okay. Now, if you consider this BLDC motor, in case of the BLDC motor, here you will be having the rotor rotation is due to the force of interaction between electromagnetic stator and permanent magnet rotor. Okay. Am I clear with the BLDC motor? Clear with the BLDC motor? Everyone? Okay, very simple concept, and it always magnets tries to attract. Okay, always magnet tries to attract. So if you check here you will be having something called the attraction. Okay, whenever the current is passed through the conductor, it will be acting as a magnet. If this acting as a south pole, then the permanent magnet will be acting as a north pole. Then always north pole will tries to attract the south pole. Because of this attraction, the current will be induced into the next alternative pole. Then this will be acting as a dummy pole. Then again, the north pole will tries to attract the south pole. The same happens in the opposite side. The south will always tries to attract the north pole. So what happened here? The rotation will get continued. Okay, here the rotation will get continued. Okay, so this is what happened in case of your BLDC motor. Yeah, that's what I am going to say. How the current is going to supplied for the stator without brushes. That you will get to know very soon. Are you clear so far? Are you clear with this phenomenon? Aditya and all, everyone? Yeah. Now, next what we need to identify is, yeah. Next thing what we need to identify, or next thing what we need to understand is, see, the point is that here I'll be having the north pole. Then my south pole should be very near to the north pole. Okay. So imagine if this pole is getting energized, instead of energizing this pole, what happened? There will not have any proper rotation sequence. Okay. So for this, what first we need to understand, which set of poles need to be energized. That is the first doubt. And next doubt we'll be getting that without brushes, how we are passing the current or how they'll be getting energized. Okay. So now let me explain both the concepts for you people. Now, here we'll be using something called our Hall effect sensors, Sandy. Okay, Hall effect sensors are something that they are some smart sensors. What I can say is that they provide the information to synchronize the armature excitation with the rotor position. Here, what happens? Here, BLDC motor will be controlled electronically. The stator windings should energize in such a sequence that it should properly rotate the motor. Okay, it should properly rotate the motor. So here, before energizing any particular stator winding, we need to acknowledge the position of the rotor. So this work can be done with the help of the Hall effect sensor. Here, what Hall effect sensors are doing? They are identifying the position of the rotor, okay, before energizing the respective stator. Okay, if you are giving the naming as CC dash, BB dash, AA dash, imagine if your rotor is near to CC dash, then you will be using something called your Hall effect sensors, where for the sensors you will be having high signal and low signal. Whenever each sensor generates high and low signals, whenever the rotor poles passes near to it, the exact the exact communication sequence will occur, and the stator windings will get energized, and the stator winding will get energized. Okay, so yeah, so here what you need to understand is, yeah, the point is that here wherever the north pole and south pole is there, that need to be identified, and then based on the north pole and south pole, the nearest pole, okay, the nearest pole need to be energized, the nearest stator pole need to be energized. This can be done with the help of the Hall effect sensor. Hall effect sensors are something which are induced into the stator poles. They'll be having the high signal and low signal. Whenever the rotor is passing near through the respective Hall effect sensor, it will be giving the high signal. Wherever you are getting the high signal, then automatically that set of stator windings will get energized. Am I clear regarding the Hall effect sensor? Yeah. How the Hall effect sensor detect the position by using the sensors. It is the sensor. By default, it will detect the position. For that, you will be having the high pass and low pass signals. Okay. So that is something different. The signals is something different. Sorry, how the high pass is passing, how the low pass signals are passing and all. So it's generally an electronic sensor which will be identifying the position. Now here we'll be getting the doubt that how the current is passed through BLDC motor without any brushes. Okay. So this is one figure which will give you the clarification, which will give you the clarity that how the BLDC motor is getting the power supply. Okay. For the BLDC motor, initially the Hall effect sensor is connected. The connected Hall effect sensor will be giving the input towards the controller. Then in the controller, you will be having the motor controller. The motor controller will be giving the position of rotor poles. Okay, the information regarding the position of rotor poles will be given towards the MOSFET gate driver. Then the MOSFET bridge will be energizing the respective stator windings. Okay, so this is for one. This is for one stator. This is for one more stator, and this is for one more stator pole pair. Okay, so each pole pair will be connected to the MOSFET bridge, and for this MOSFET bridge again connected towards our something called our battery, something called our vehicle controllers. Okay, so from here you'll be having something called vehicle controller and battery, having the proper circuitry where the Hall effect sensor is identifying the position of rotor. The input will be given for the motor logic controller. Then the input is given for the MOSFET bridge. From there, the MOSFET will be energizing your stator windings. Is that clear? Someone is asking, does EV contains engine? I think they are new for the class. How does the placement and signal pattern that is done with the help of the sensors? So now you got the clarity regarding this. Okay, how the signals, how the placement is happening and all for everyone. Can you quickly respond in the chat box? Is that clear for everyone? Yeah. So once again, let me quickly wind it off that in case of the BLDC motor, where you will be having the Hall effect sensor, which is identifying the position of the rotor. Then the identified position of the rotor input is the information is given to the motor logic controller. From there, the input is given to the MOSFET bridge. Okay. Then the MOSFET is energizing the respective stator windings. Whenever the stator windings is energizing, that stator winding will be acting as a electromagnet. That electromagnet will be attracting the permanent magnet. There again, you will be having the magnetic interaction. Because of the magnetic interaction, next alternative pole will get energized. Okay, is that clear, Venkatesh? Yeah. Coming for the advantages and disadvantages with respect to the BLDC motors are advantages, they don't have any mechanical commutator. Then they'll be very high efficient. Okay. Then what I can say is they'll be having the high speed operation range. Then they'll be having something called the proper motor geometry, where they can also used in very low applications. And they'll be having the higher dynamic response. They'll also be having the very, very low electromagnetic interference. And coming for the disadvantages, they are very, very costlier. Okay, and one more thing what I can say is because of the complex drive circuitry, they are more expensive. Okay, so all of you clear regarding the BLDC motor? Let us quickly conclude the BLDC motor by seeing the applications. They are applied. They are used in hardwares, CDs and DVD players. Okay, then they are used in electrical two-wheelers. Then they are used in washing machines, fans, pumps, and blowers. So these are the advantages with regarding the BLDC motors. Okay, so the point is that as an electric vehicle engineer, there is no need to learn in depth of every motor, because if you know the applications properly, then directly we can use that motor. Okay, if you know the application and working principle, then it is more than enough for the selection of the motors and all. Okay, now coming for the next type of motor we'll be having is called something called the AC induction motor. So induction motor is something which is widely used in the industries, where you will be having the three-phase power supply. So if you take the proper induction motor will be working on Faraday's law of electromagnetic induction principle. Okay, so here let me quickly explain. In case of the induction motor, you will be having something called your stator and you will be having something called your rotor. Now what happens whenever the three-phase power supply is given to the stator, because of the three-phase power supply, the stator will be producing the rotating magnetic field. Okay, RMF will be rotated. Okay, that RMF will helps to rotate the stator. Okay, the working principle behind the three-phase induction motor is Faraday's law of electromagnetic induction. When the three-phase supply is given to the stator, it creates a rotating magnetic field. The rotating magnetic field rotates at the synchronous speed. You need to remember the speed at which rotating magnetic field rotates is known as the synchronous speed. Okay, now what happened? Whenever the rotating magnetic field is rotating, because of the Faraday's law and all, the rotor starts to rotate. So whenever the rotor starts to rotate, the speed the speed at which your rotor is rotating is known as the slip. Okay, the speed at which your rotor is rotating is known as the rotor speed. That is your NR. Here you will be having something called NR and NS. Okay, so what happens if NR and NS rotates at the same speed? In case of the induction motor, there will not be any flux cutting. Okay, flux will not cut the loop and there will not be any induced EMF. If you don't have any induced EMF, the current cannot be produced. But whenever you are coming for the proper induction motor working principle, the rotor should be always, the rotor speed should be always less than the stator speed. NR should be always less than the stator speed. Okay, see, the point is that the flux need to cut the loop, then only EMF will be induced. Whenever the EMF is induced, because of the Lenz law, the current will be produced in the bars of the rotor. Okay, so this is the case where I can say that NR must be less than NS. And in case of the induction motor, always NR tries to attain the speed of the rotor. Okay, the speed of the rotating magnetic field. NR is always trying to match the speed of NS. Now here a question for you people. How do we control the speed of this induction motor? Okay, what is the speed control method we'll use in the induction motor? Can anyone say? Okay, so yeah, rather than the voltage control method, mostly here we'll be using something called your frequency control method. Okay, variable frequency control method. Okay, so here, if you properly observe, NS is equal to 120 F by P, where my synchronous speed is always proportional to the frequency, where my synchronous speed is always proportional to the frequency. That is the one equation where I'll be having. The next thing I'll be having is that always my rotor speed is tries to attain the synchronous speed. Always my rotor speed is tries to attain the synchronous speed. So if this is the scenario, NR is directly proportional to the NS. So if A is proportional to B and B is proportional to C, then automatically A is proportional to C. This is what we have studied in the basic mathematics. So if we apply that scenario, my rotor speed always proportional to the frequency. Now, if I can control the input frequency, then I can easily control my speed of the motor. Then I can easily control my speed of the motor. This is what one good feature or one salient feature with respect to our induction motor, where the industries are majorly looking after it. Okay. Now coming for the applications, they are used. They are nearly used for a constant speed. You will be having a simple and rugged construction, and the power factor is lagging. The power factor will be in between 0.75 to 0.9. And here the uses of your induction motor are, they are used in water pumps, they are used in drills, latches, elevators, and all. Okay. Now coming to the applications. they are used in four-wheelers. For the four-wheelers, one of the better vehicle, one of the better motor is BLDC motor. Then you will be having something called permanent magnet synchronous motor. Okay, so this is regarding your BLDC motor and the advantages. This is regarding your induction motor, and we have seen the advantages. Like they are rugged and reliable. They are self-starting. They'll be having high starting torque. Then they'll be having something called regenerative braking. Then they'll be having something called good speed regulation. All of you clear with this AC induction motor? Yeah. So very soon I'll finish the session by explaining two different types of the motors. Then we can wind it off for today. The point is that where I can say that whenever we are dealing with this master classes and all, we'll be having very short duration of time where we can only cover the outline of the complete picture. But when you are coming for the internship programs or when you are coming for the full-time programs and all, so the same concept of the AC induction motor will be explained for 6 to 8 hours. Okay. In case of the internship programs and in case of the regular programs, because here if we are only dealing with single concept where the time may not be permits, so that's what where we need to be more precise to complete the majority of the things. At least you need to get the proper outline, where if you start from one point and if you come back to the same point, then the loop will be closed. You will be getting at least a closed loop idea regarding the technology, so that it will be somewhat better. What I can say is something is better than nothing. Okay. Now coming for the next two types of the motors I'll be using here are from where this came. Okay. Yeah. Next two types of the motors will be having something called our permanent magnet synchronous motors, where these are also one of the what we say, one of the second favorite motors in our industry, where I can say that permanent magnet synchronous motors are highly efficient motor. They are widely used in electric vehicles where its rotor consists of strong permanent magnet. Okay. Here the one advantage we'll be having is the stator will same works like as AC induction motor. In case of this permanent magnet synchronous motor, also stator will always produces the rotating magnetic field, and the rotor will be producing the permanent magnetic field. Now here what happened, in permanent magnet synchronous motor, the rotor locks into the synchronism with the stator field. There is no slip. Okay, whenever you are coming for the AC induction motor, we are having the slip application where NR is always less than NS. NS minus NR by NS will be your slip. But whenever you are coming for the permanent magnet synchronous motors, here you don't have any slip operation, Andy, because your rotor and stator always in the synchronism, they always maintain the proper synchronicity. Okay, they always maintain the proper synchronicity. So here you don't have any disturbances regarding the synchronism. So here what happens, the permanent magnet motors are known for the high efficiency. They are mainly known for their power density. They are mainly known for their quiet operation. And one advantage they'll be having is that they'll be having very good performance. Okay. So they are made up of the permanent magnets, where I can say that they'll be having the compactability in size also. So this makes the advantages with regarding the permanent magnet synchronous motors. So if we consider today's electric vehicle market scenario, majority of the two-wheelers are working on the BLDC motors, some are on the hub motors where the hub principle will be working on. Then the majority of the cars will be running on induction motors and permanent magnet synchronous motors. And a few of the trucks are running only on the switched reluctance motor. And still the SRM motors are something that they are in R&D stage itself, where it will take a lots of time, lots of effort need to be kept in the this switched reluctance motor, because even though switched reluctance motors are very robust and cost effectiveness, they'll be making a lots of noise while they are using, and they'll be creating a lots of vibration. Now, what I can say is, if the noise is avoidable, or if there is no problem regarding the noise emission, then we can go for the switched reluctance motor, or else it's better to quit regarding the switched reluctance motor. Okay, so clear with the switched reluctance motor and permanent magnet synchronous motor. Clear for everyone? Yeah. So the point is that one thing I can say that if it's a master class where you'll be getting the proper outline of the concept, but whenever it comes to the internships and the full-time programs, where you will be getting very in-depth of the individual motor, because as a motor expert, I can say that I'll be taking the 6 hours for induction motor principle itself. Okay. So someone is asking to explain the last slide, that is the switched reluctance motor. See, one thing I can say that whenever you are coming for the switched reluctance motor, there you will be having something called your salient poles. Okay, so in case of the switched reluctance motor, you will be having something called what we say very noise application. So that is what the disadvantage with respect to the switched reluctance motor. Coming to the permanent magnet synchronous motor, in case of the permanent magnet synchronous motor, for the stator you will be having something called a rotating magnetic field, and for the rotors you will be having something called permanent magnets, which are creating the strong magnetic field. Here what happens, there is a proper just a second. Okay, now the difference between your the thing here coming in case of your permanent magnet synchronous motor, one thing what I can say is here you'll be having something called your rotor, where you'll be having permanent magnetic field. You'll be having stator, where you'll be having something called your rotating magnetic field. Here the rotor magnetic field and stator magnetic field will get synchronized and will get interlocked. They'll be rotating at the synchronous speed. This is what happens in case of the permanent magnet synchronous motor. Clear? Yes. So now let me quickly wind it off by saying few other motor selection criterias. Just bear with me for 5 minutes and we'll be having a quick doubt session. Yeah. Now, finally, we have seen regarding all the different types of motors, how they are working, what happening in them and all. Now, let me finalize something that how to select the right motor. Okay, that is what the main thing. Even though if you are knowing large things regarding your motor, that does not make sense unless until you will get to know what we say the criterias. Few criterias we have already discussed, and now coming to end the final criterias we'll be having for the selecting the right motors are these criteria you need to remember properly, because whenever you are working on vehicles to select the motors, this you need to check properly. First thing is the vehicle characteristics, where which includes the mass of the vehicle, dimensions of the vehicle, which includes the range possibilities of the vehicle. Then you will be having something called your driving cycles, number of charging and discharging cycles your battery can afford, and number of driving cycles your motor can afford, which will give the capacity of the motor, if I am not wrong. Then you will be having something called your vehicle configuration. Either it is electric vehicle or hybrid vehicle, you need to be more precise. Then you need to select the motor. Then you will be having something called your maximal speed. Okay, so what is the maximum speed you need to target, that you need to check while you are selecting the motor, because your motor need to sustain, or your motor need to supply the maximum speed, even it is in the road conditions or it is in the off-roading condition. Okay, in the on-roading condition and in the off-roading condition, it need to supply the maximum speed. Then you need to check the maximum torque. Whenever the speed is 0, if your motor is giving the high torque or not. Tomorrow I'll show the torque speed graph, how the graph is extracted in the MATLAB and all. Then we'll be having something called the maximal power. What is the maximum power output we'll be getting from the motor? Then vice versa, we need to check the battery capacity also, because imagine I'm having the motor of 60 volts, okay, equivalent 60 volts motor I'm having, and I'm using 5 volts battery, then it will not make any sense. Okay, so there should be a proper matching between the battery ratings and the motor ratings. We need to check the battery motor capacity and battery voltage also. Then we'll be having something called the gearbox. Is it a gear vehicle or it is a non-gear direct vehicle, that we need to check. And finally, the one thing we need to check regarding the motor selection is cost. Okay, cost is the one thing where we need to concentrate, where we need to check regarding the vehicle motor, regarding the selection of the vehicle motor. Okay, so this is from my side for today. We have seen all the different types of the motor, and we have seen what we say. We have seen how to use the different motors in the different applications, and then we have seen the selection criteria of the motors. Okay, so quickly the motors, one last time I'll be saying, the motors we are using for the electric vehicles are where is the slide? Yeah. So one last time, I want to show you people that these are the motors where we are using in our day-to-day life, day-to-day electric vehicle life. One is the BLDC motor, next is the permanent magnet synchronous motor, next induction motor, next you'll be having something called switched reluctance motor. In this, BLDC motors are used for two-wheelers, permanent magnet synchronous motors and induction motors are used for four-wheelers, and switched reluctance motors, because of their noise issues, they are only used for normal truck applications. And coming to the efficiency point of view, in case of the DC motors, BLDC motors are efficient. In case of the synchronous motors, permanent magnet synchronous motors are efficient. And in case of the asynchronous motors, induction motors are efficient. And it is difficult to compare among them, because every individual motor will be having their own specifications and own efficiency. So we need to check the specs along with the efficiency. So if we want to compare in the bare level with respect to induction motor and permanent magnet motor, I can say induction motors are somewhat more speed efficiency, because of their easy speed controllability due to variable frequency drives we are using. Okay, Shalom guys, this is from my side. We have done with the motors. Okay, sir, is this the only motors or this much only we are having in the motors? And motors are something that where they are the ocean. Okay, you can't learn the motors in just 1 hour. At least it may take 2 to 3 days or 3 to 4 days, where if you properly sit on the motors, or where if you listen the motor in general technology. Where as an trainer, what I'll do is for the internship batches or for the regular batches, what I'll be doing is for every motor, I can explain the working principle, I can explain the operating principle, I can explain the torque speed characteristics and all. But due to the time, what we say, due to the time shortage, what we can do is we can give the overall overview of this. I think this is also more than enough to know what happening in the vehicle and all. So am I clear for everyone? Guys, is that clear for everyone? Can you quickly respond in the chat box? Purna Chandra Reddy, do you have any doubt? Purna, is there any doubt from your side? Is it clear for you? Yeah, Hari, I have explained the BLDC motor twice, if I'm not wrong. BLDC motors are something where you'll not use brushes instead of the brushes and all. You'll be using something called your Hall effect sensor, where the for the BLDC motors towards the rotor you will be having the permanent magnet. For the stator you will be having electromagnet. So whenever the power supply is given, electromagnets will tries to attract the permanent magnet. But whenever the attraction between the electromagnet and permanent magnet will happen, then due to that attraction, the next pole will get energized. Then because of the next pole will get energized, always the rotor will tries to attract the next pole. So there the rotor rotation will get continuous. For energizing the stator, we need to identify the rotor position. That can be done with the help of the Hall effect sensor. I think it's clear now. Hari Krishna. So if it is clear for everyone, if it is so, what I can say is it's done from my side. The session is open for doubts. You can ask doubts for 10 minutes, then we can wind it off. Yes, yes, Amir, you are correct. See, the point is that for this windings and all, if you properly refer to the DC motor, brushed DC motor, whenever the number of windings is increasing, then what happened? The rotation of the commutator ring will be increasing. So then automatically what happened? The sliding will get more easier. Then automatically the power of the motor will get increased. Okay, the speed of the motor will get increased. So more number of windings, most the speed. That's correct. Hey guys, the session is open for doubts. You can ask your doubts. You can post your doubts in the chat box. Yes, the point is that it's not the big motor. What I can say is it's regarding the capacity of the motor. For the four-wheelers, you need to have high capacity motors as compared to your two-wheelers. Yeah, if you generally take your electrical bicycles, okay, or electrical two-wheelers, okay. In case of the electrical bicycle, we'll be having something called 250 watt to 500 watt motor power, where the voltage required is 36 to 48 volts, okay, and the top speed which can offer up to 25 kilometer per hour. Whenever you are coming for the vehicles, the two-wheelers and all, the two-wheeler vehicle motor capacity will be ranging from 1.5 kilowatt to 25 kilowatt. It based on the variant you will be having. If it is the premium, you will be having the 25 kilowatt. So whenever you will be having the 2 kilowatt to 5 kilowatt, your speed, the maximum speed or the maximum RPM you can get up to the 60 to 100 kilometer per hour. Then whenever you are coming for the car batteries, there you will be having the 30 to 50 kilowatt hour batteries for small vehicles, and up to the high vehicles you will be having 750 kilowatt. Okay, so here what happens, the motors are varying from 250 watts to 750 kilowatt. It based on the vehicle variant to vehicle variant. Okay, this is how the capacity will be changing. Someone is asking that how many poles are used in electric EV motors. It depends on variant to variant, and typically if you are going for the BLDC motor, you will be having the 2-pole pair to 10-pole pair motors. Then if you are going for the three-wheelers and all, you will be having again 6-pole pair to 12-pole pair motors, and it depends from variant to variant. Yeah, someone is asking what is the RPM. RPM is something that the revolutions per minute. Okay, so that's not for electric vehicles. We'll be considering the RPMs for your motors only. Okay, so the motor RPM itself reflects the vehicle RPM. In generally, for the bikes and all, you will be having the RPM of 1000 to 6000 RPM revolutions per minute you will be having. Then whenever you are coming for the high-end vehicles and all, you will be having 5000 to 20,000 RPM. Yeah. Thank you, Amir. Next, someone is asking what is a driving cycle. Driving cycle is something that the curve extracted between your speed and time, okay, which will giving the profile of the vehicle, how much time, how much speed you are maintaining, which will be leading you to the efficiencies and all. That is how your driving cycle will be determined, or we can say that it's a standardized speed versus time profile. So which helps to measure the efficiencies and all. In generally, in case of the electric vehicle, we can use the steppers and all for increasing the motor speed. Then anything else and any doubts from anyone? Or shall we wind it off the session? Someone is asked something that do EV cars have handbrakes? Yes, and we will be having the handbrakes for EV cars also. So if everything is clear, we can wind it off for today. The point is, one thing I can say that it's because of the decrease of capacity of the battery, and one more thing I can say that the internal winding issues.
Manjunath,
Yes, ma'am.
yeah, I think we are done with session and out session, right?
Yeah, it's done with the out session. So this is for today, guys.
Thank you, Manjunath,
Yeah, we don't.
available
Yeah,
time and
thank you.
insightful content. And thank you
Yeah.
everyone for your patience and participation. See you all tomorrow at day 5. Thank you.
Yeah.